Next up, I wanted to actually run through an example of looking at a simulated problem and trying to extract all this information we've been talking about and kind of write it all down. In this problem, it says that four partners, P1, P2, P3, P4 for our player reference numbers, decide to start a new business venture. In order to raise the $200,000 capital needed for startup, they issue 20 shares worth $10,000 each. And right, 20 times 10,000 should be 200,000. And each of those shares will help to make sure they get the money they need. And it says then suppose that player 1 is going to buy 8 shares, player 2 buys 7 shares, player 3 buys 3 shares, and player 4 buys 2 shares. Therefore, they can get, once all those shares are done, they have the money that they need and they're ready to go. And we kind of have a split ownership based on the different contributions. And it says, assuming the usual agreement that one share equals one vote in the partnership. So if we're wondering, well, how is the voting going to work? Well, basically, player 1 should get 8 votes because they bought 8 shares. Player 2, 7, and so on. It says, suppose the quota is set to be 2/3 of the total number of votes. Now, notice it doesn't say 2/3 majority. So this, again, is kind of bringing up that, well, am I supposed to round up or not? But you actually always round up regardless of whether it's a majority or not. But also the whole thing, does it have to exceed or match? Anyways, but first thing it says to do is describe this weighted voting system using the bracket notation, and then identify all the winning coalitions using the brace notation. So go ahead and pause it here. Try to think, see if this is all making sense, if you can write it all out. And if not, I'll go ahead and solve it now when you unpause. So let me bring up the packet. It should be on the next page, I believe, and we'll get going. So with the weighted voting system notation, so we always use brackets to do that. Sorry, I need to zoom in on my tablet. So we always start with the quota first, which it does not actually directly give us, but it does tell us how many votes each person is going to get: 8, 7, 3, and 2 based on the shares they purchased. And then the thing I need to know is, well, what's the quota? So first off, what I would do is calculate the total number of votes, which there's 20 shares, so V is equal to 20, and then figure out, well, what is my determination for Q? It says it's supposed to be 2/3 of the total number of votes. So if I take 2/3 V, that'd be 2/3 of 20. And in that case, that would be 13.3 repeating for the 2/3 vote. And even though it doesn't say majority, the question would be, should I round this up or down? And your inclination might be to round it down because it's closer to 13 than it is to 14 on a purely arithmetic scale. But actually, remember the idea of a quota is you need to meet the quota. If we think about, if we were to set this as 13, which is actually not right, uh, notice that technically we're not making it to the level of 2/3. That's under the level of 2/3 because an exact 2/3 measurement would be 13.3. And in order to pass the motion, we have to at least make it to that quota. Since there's obviously not a fractional number of votes, you can't have 13.3 votes. So the next best thing will be, well, 14. 14 is the first possible set of votes that would actually meet the quota because 13 is not going to make it there. So when I say you have to make it to the quota, that's true. But essentially, if you ever get a non-round decimal, you're always going to round it up regardless of whether it says to take a majority or not. Just because rounding it down is always going to shortchange the needed quota for the particular situation. And once we know the quota, we can then find all the winning coalitions. And also, the quota is very important because if the coalitions may or may not be winning depending on that number, right? The quota is very specific, and if you change the quota, it will change which coalitions are winning and losing. And some of your homework questions will ask you, or typically they'll ask you to get into, well, what if the quota is this? What if it's that? How does it change your outcomes? But basically, to then find the winning and losing, well, actually, it doesn't even ask us to find the losing coalitions, so we don't need to bother. We could then do exactly what we did before. Basically, look at, well, what are the different ways that these voters could come together to make it to the quota? And actually, what I usually like to do is start with everybody all together. So the grand coalition should always win. If everybody says yes, then it's unanimous. That would be one winning coalition. Also, what I like to do is go from 4 down to 3. So I could now look at my 3-player groups. 873 would be one, and that's definitely going to be winning. Sorry, my phone's blowing up, which is really distracting. Go away. Um, but that would be 18. Again, basically add them all up, make sure they meet this number. 872 would be another option, or 8, and I believe that's it. Because say I was to look at 732, that's not going to be winning, right? Because that's only 12. Or even 832 would not work either. And remember, there's actually going to be there's only going to be 4 3-player groups. And I could look at literally all of them if I wanted to. But actually, the losing ones are not going to be important because they're not relevant, and we'll talk about why when we get into the bonds off distribution soon. Then I would move to 2-player and so on. So for 2-player coalitions, I believe 8 and 7 is the only combination that can win. Because if 8 or 7 are paired with any of the other 2 voters, they're definitely not going to have enough to make it to 14. So there's actually 6 2-player coalitions in this case, and only one of them's winning. And so notice that depending on the numbers and depending on the quota, there could be, the type of solution could vary vastly, right? Like in the last example, we had a lot more winning coalitions because the quota was lower. But when the quota is higher, there's less ways to pass the motion, and so it gets a little bit more restrictive, which might be good and might be bad depending on your desire for your weighted voting system. But that will wrap up this example. In the next video, I'm going to start talking about some of those terms from 2.1, such as anarchy, gridlock, talk about the necessary restrictions to the quota, and get into some examples of what we call a dictator, dummy voter, and veto power in these systems.